Hi. I've been wanting to sort of create a video on TDD for a while, just because I think it's quite a fascinating approach to take for writing code, and in the cases where it works, I think it works really well. There are some out there who say that everybody should use TDD all the time, and and I'm not necessarily one of those people. I prefer to take it from a sort of practical point of view, and but I do know that I have been able to write code with TDD that I possibly wouldn't have without it, just because the complexity would have probably made my head blow apart. So, and it's actually changed the way that I think about writing code in some ways, and I think it's not necessarily a bad thing to be exposed to. So, this is a bowling kata. There seem to be a couple of different ways to do it. This one, you give it a complete set of bowling scores, like an entire game's worth, and then it calculates the score. And that's the one that I'm going to go with because it's sort of a nice functional approach. There's another sort of approach that some people take, which is that they actually have an object and they add roles one by one, which is quite stateful, and you could end up with some interesting intermediate cases and things. So I think this might be actually a more straightforward way to go. So we'll give this a try. There's certain caveats like not checking for valid roles, for correct numbers, roles, frames. So we're assuming that the string coming in is going to be, a valid game of bowling. And what we want to spit out of it is the score for that game. So the approach with TDD, and I'm going to show you a little diagram here. Actually, this is a bigger diagram. You'll hear about something called the red-green refactor cycle. And you start here, and you create a test. Now you notice it says write a test. There are some people I've run into who want to write a whole bunch of tests all at once in the beginning, and but there are problems with that. And well, let's go through the process the way this is first. So you write a test. You see the test fail, and this is important. You actually want to actually see the test fail because, first of all, the writing the code is going to fix something. But two, you also want to see how the test fails because you want to make sure the test is failing for the right reason, because there actually might be a problem in the test. So seeing the test fail for the right reason means, okay, I've got the case that I want. Sometimes you can't tell from the test failure if it's right or not, but sometimes you can. Then you just write the amount of code that it takes to make that test pass. And the typical statement is you want to write the smallest amount of code possible. I mean, sometimes you feel the urge to write more, but the idea is to write, just the code to get the test to pass. And this is something that has, as I said, sort of changed the way that I look at code, because I see code now as being more of this sort of ongoing process of development. Once the code passes the test, then you get into what's called the refactor stage. And at this point, you basically want to look at your code and say, okay, is there something I can do to refactor this code to make it look better? Because I basically just kind of jammed some code in there to get this thing to pass. And now, is there something that I can do to actually make it sort of make sense? So this comes back to that thing that we had seen before, which is make it work, make it right, and then make it fast. So the first bit of this is make it work, and then the refactor part is sort of make it right. The problem with doing all of your tests up front is that you never get back to green until you've actually written all the code. So if you have every test up front, and then as you're trying to fix them, some may go green, but some will stay red. You never actually get back to a green stage where you can actually refactor. And I think it loses what TDD is all about, which is really an incremental approach to software development. I think more importantly as well is that the test that you write, well, first of all, the code you write is based on the test that you've written. But when you come back around, the test that you write next is actually based on the current state of the code. You can't necessarily know up front what tests you're going to need. I mean, you kind of can. You can guess based on, what you think the code's going to have to do, especially if it's something like Roman numerals or something like that. You can say, okay, I'm going to need, X, C, and V, all those sorts of things. But what I found works really well is that if you if you think, okay, what's the next step that I can take in my code, and then write a test for that, it actually leads you through a process of incrementally developing your code. And that's something that you can't do by writing all of your tests up front. I mean, maybe you can, maybe some people can, but I can't anyway. All right, well, that's enough preliminary for that. I just wanted to give some sort of context because, you know, the process I'm going to go through might seem a bit strange. All right, so let's get a test file set up just so we can do something. Now, the way the Python's set up, files have to begin with the word test. I'll just call it bowling. And we'll grab some boilerplate from one of these, which is pretty much, I probably should know this stuff, but I don't. And we have our test. Okay, we'll call it bowling tests with a space. Okay. Now each function within this has to start with test as well, because there might be functions in here that are just used for you know, helpers or whatever, and you don't want those to be run. So what would be our simplest test case? You know, what would be a very good starting point? So we want something where we basically feed it a string and we get a value back. Now, traditionally, and I'm going to stick with this, the first test case for the bowling thing is all zeros. So basically, if somebody bowls 20 gutter balls, then that will be 0. Well, it should be 0 because they're gutter balls. So, I'm sorry, I started to think about something else. What do we want to call this? Let's just say frames. So this is going to be 20 zeros. They want to use dash. Let's do what they were saying. So 2, 3, 4, 5, 6, 20. Okay, so we've got 20 dashes there. There's probably a really good way to do this in Python where you could replicate strings and things, but I'm not going to spend the time to go look that up. And so now we can get a score, and it needs to come from something. And I'm not going to bother with the whole object-oriented thing because this is going to be fairly functional. So let's just call it compute score frames. Now let's see if this thing is going to be handy. Create function. Hey, here we go. So the first step we had here, we couldn't even run this code because there was no function. So now this has allowed us to actually have a function and assert equal. Now there's an annoying thing with these unit tests which really bothers me, which is that when you make an assertion, if it fails, it's going to print out, this is what I expected, and this is what the actual value was. For some reason, this sort of assertion, the expected value comes first and the actual comes afterwards. Normally you would want to say assert equal, assert the score is equal to 0, but they have it reversed. So it's just one of those things to keep in mind that if you want the actual output to say something reasonable, you have to kind of do it in that order. Now this is unhappy because it's going to say, hey, it doesn't return anything, but let's give it a run anyway, because this is Python. Okay, so we said none is not equal to 0. So we expected a 0, and we got none. So what's the simplest way to make this test pass? And this is where some people often get tripped up. The actual simplest way to do this is just to return 0. And here we go. We have a passing test. Now, I was watching a video once where somebody was doing TTD, and he says, oh, but that's wrong, because it hasn't tested this. And then he started adding code to do checks for ifs and all of this. And he actually ended up putting an if-else in. And that's when it dawned on me. So one thing that happens is if you follow TDD the way that it's described, is that you actually end up with 100% code coverage. And that's because, well, unless you do something totally horribly wrong, but it's because every piece of code that you put in will be covered by one of these test cases. So when someone wants to go in and say, okay, well, if it's this, then return 0, then you need to have the else. Okay, well, what happens in the other code branch? Well, there's no test for that. And so this is where it's really important with TDD, at least from my point of view, to actually just do the minimal amount of code that it takes to get things to pass, because you really want to make sure that every line of code you have is justified to some extent by a test. Now, of course, that's philosophical and theoretical and all that, but I mean, that's sort of the goal in some ways. Okay, so we have our first passing test. Oops, that's all gone, so let's get our next one. So what would our next one be? Well, let's just say somebody gets all ones. Okay, so we've got 20 ones. And we would expect our score to be 20, because that's what it would be. Now if we run this, okay, we got 0 and we wanted 20. So now we have to actually do something with these frames. So let's start out with 0. Let's say we just did something naive. Can we just do plus equals? We did something like this. Now, if we ran this test again, oh, it's still not passing. Okay. Oh, because I have to return score. Like, hey, it passes, but we've actually broken this one because we can't actually do int of a dash. So let's just do and they both pass, and it's fine. So this shows them, for one thing, is that actually making one of the test passes, making one test pass could actually break another test. But by having this test suite, you actually make sure that as you're adding new functionality, you're not breaking old functionality. The other thing that's nice about this is that the amount of changes we're making here are actually fairly small for each test to get it to pass, and sometimes even to fix something. Like, for instance, I added an if here example, which gives us our branch across these two. Okay, so now we're at this interesting point. So if you think about the code so far, we actually have everything we need to score a game that doesn't have any sort of spares or strikes. And that's, just with this amount of code. So let's test a spare. Actually, let's test a, I don't know, that's the thing, it doesn't matter. Okay. Either one, it's gonna do it. So let's grab this guy. So let's say we have that. So basically we have, well, these are going to be our 18 from before, but now we have 10. So it's 28, but we also have to add the 1 for the next one, so it's 29. So assuming I have that correct, yep, I think that's all right. Okay, and yeah, it doesn't like the slash either, so okay, let's just go with this. See, there's a couple ways to do this. One is you could actually have this just be 9, for example, and because technically you have 9 pins. You could do the same thing with this. This could be just zeros. In fact, if these were all zeros, it would actually still work. So that's something else to keep in mind. I'm really tempted. Let's. Well, no. Let's stick with the requirements the way they are. So. Now this is where it's going to get interesting, because we're stepping through the frames one by one, but we're going to have to actually do some look ahead. So the first thing I'm going to do, I'm actually going to comment this out for the moment. And I'm going to refactor this. I don't know how Python-y this is going to be, but well, no, actually, I don't have to do that. Okay, sorry. This is no, I'm going to have to. So we're going to have to skip forward when we actually process this thing. Okay, so the reason I've done this is because now I can actually run these tests again and make sure. Okay, everything is still passing. Okay, so I've done my little refactor here in anticipation of what's coming. Okay, so we'll get back to this guy, and it should still fail for the same reason, because it doesn't like the slashes. Okay, so let's say if frame equals slash, and I guess I have to do two slashes, because, ooh, that's, okay, now which slash is it? Okay, forward slash. Jeez, my brain. Then we want to, let's see, this is where it gets interesting, because we need to know sort of what the previous one was. This is why this slash notation is a real annoyance. So we want to do score equals score plus 10 minus index minus 1. So we want the whole thing to add up to 10. But we want to subtract off what's already been done so far with the previous frame. And then we also want to say plus 1. Okay, this is horrible code, but let's just see if this passes everything first. Okay, no, it doesn't yet. What did we end up with? Oh, gosh. Wait, what? 10? Ah, right, it's here. And ooh, let's see, it's going to be an interesting test case if we had a strike next, but we just have to get this to work for now. Okay, so everything's passing now, so that's good. So let's refactor this a bit. For one thing, we don't need to have all of this. Just say plus equals. Okay, maybe that'll still all work. Yes, okay, so we're good there. So now let's do strike. Now the assumption, of course, is that, you know, if this is a spare in one place, that it's going to be a spare somewhere else. I mean, we could actually test that. We could say, okay, let's try 2 spares. And this is why it's really important to sort of be in a red state to begin with. So let's say that, well, I'm just picking a random spot. That's not good. Let's say we had that was a spare, and then that was a spare. So we have 10, 11, 21, 22, oh geez. Well, we're going to add, I think it's 11 more onto this, so that would be 40. Let's see. Of course, you know, it's 38. Well, see, I'm not doing this very well because I really should actually know what this is supposed to be ahead of time. It's only added 9 onto it. Is that right? Because we added... Oh, no, we added 8 on, plus we had the 1 more. So yeah, so 9. So, okay. So anyway, yeah, that's already passing. So we could have this test, but there's no real need for it. So let's turn this into something else, which is let's test a streak. And so let's just say, do capital X. Let's do capital X. 17, 18 ones. So this is all going to be 18 plus 10, 28 plus 2 is 30. So we can see that strikes are slightly better than spares. Now if we test this, it fails because it can't convert the X. See, I don't really like the way these are failing. This is a problem with this because it's not failing for good reasons. It's failing because we have these funky type things going on. Okay, so if we have a strike, we add 10. We don't have to worry about that because it's the first ball in the frame. And we need to add the next 2 balls. Now one thing you'll notice is that we don't actually carry, we could be running off the end of the frames, for example. Again, this is one of those things where we could actually add a test case eventually for not doing that. But you know, we can do that step by step as we need to. Okay, and now everything's passing. So, okay, now we're fine. So this leaves us with some interesting cases. So now knowing the code here, this guy is okay because, whoops, not that guy, this guy here, for a spare, this guy being a spare means the previous value had to be, it couldn't be a spare or an X, it had to have been a number, so that's fine. But what comes afterwards could be a strike. And if we have that case, then we need to do something special for that. So let's do that because that's going to be an interesting thing. So let's do a spare. So these next 2 are just going to become our strike. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, which is what we want. So this 10 plus this 10 makes 20. Then plus that 10 is 30, plus 2 is 32. And then we add 16 onto that. Yeah, 32 plus 16 is 48. Assuming I haven't totally botched that up. Now when we go to run this and we want to see it fail, it's going to fail again because it's trying to do an int on something that it can't. And in fact, it takes us to the line of code that we need to worry about. So this is the problem here. Let's fix this. so this is just a little bit of some hacky code in here to see what happens. Okay, so everything's passing. All right, so that's fine. Now this is where we're in a green phase, and we possibly want to go, okay, this is not such a great thing anymore, because we now have this sort of logic elsewhere about 10, for example. So let's do something which is frame value. This is what we want to do. Well, let's just encapsulate this into a function, just because it might actually prove useful. So let's create a method. Oh, that didn't work. Nope, that's not working either. Okay, well, there's some way to refactor it. Let's see if I can do this here. Refactor, extract method. That's why, because I'm in the wrong spot. Okay. And now we can just inline this, and we're fine, and we can inline that, and okay, now we're fine. So, the reason why this is useful now is because of our next test, which is going to be, actually, before I do that, I don't know if I ran this again after that. Let's make sure this still runs. Okay, yeah, it still runs. Okay. So we have, let's say we have 3 strikes. So we have 3 strikes, and then we have, let's just say 7 frames of 0. Just to keep life simple. Ooh, actually, we're not doing the 0 either. Aha. So, is that right? So we have 14, that's 7 frames then, okay. So there's another case after this, which is the 3 zeros. So this is going to be 30 plus 21 plus 12 plus 2 times 7 plus 14. So I'm actually just going to do this because I'm lazy. Whoops, I put that in the wrong spot. And let's see what we get when we run this. Right, so we've got invalid literal print again, but it takes us to the line which is here. So now that we have this, we have our nice fancy frame value function, we can actually just do this. And if we run our tests, everything's green. So once again, we've incrementally added some functionality to this guy. Now let's do this one. I'm just going to put it down here. Test to spare. With 0. So what happens if the value right after the spare is a dash? We would expect it to be 28. And it should fail because it doesn't know how to deal with the dash. And fortunately, we have a handy little function now that we can do this. God, how do you do? I'm gonna just make this more sane. just realized that calling this next frame doesn't make any sense. So let's just call it frame. And now let's run our tests and see. Oops, still failed. Okay, what did I do wrong? Okay. Oh, I forgot to wait. Right, because we got rid of the 1, so it took it away from the spare end. Okay, sorry. I hate when I do that. Yeah, okay, so that's what it is. The code's smarter than I am. Right, so now we've got quite a bit going here. So what we don't have is the handling for the end of game. And this is where it gets interesting, because we actually don't want, well, let's say a perfect game, for example, which is, in fact, let's just write a test for that. Test perfect game. And a perfect game will be 10 strikes plus the 2 more we need to take care of the 10th frame. God, birds. And this should be 300. Now the problem we're going to run into is that the code's going to run off the end of this, and it's going to try to access off the end. But let's make sure that it actually fails the way we think it will. And we come down. Yep, index out of range. Okay, so that's what we expect. We expect it to actually do that. So what's the best way to do this? I mean, we could track everything, or we could just say we're just not going to walk off the end. In fact, let's just do that, because that would actually work for partial games as well. So what we'll say is if index -2 we actually need it to be minus, no, yeah, less than -2. Okay, so actually let's just see what happens. Okay, yeah, so that works for that. Now it means that if you ever had an x at the end of this, at the end of the string, it just won't count it, but that's sort of what you would almost want to do anyway. So now let's test an almost perfect game, which would be, I don't actually know what this would be. So let's do this a different way. Let's say spare at end. So we've got all of our dashes here. Except we're going to have spare. And what comes after that? Well, let's give it a value, like let's say 5. So that should give us 15 as our score. Actually, that should actually just work. Huh. Unless I got the value wrong. Ah, see, I was wrong. The value before. Okay, this is actually testing something that is actually a failure, so there we go. See, I was just wrong in my thinking. So the actual is 20. So did I just... Right, because you're not supposed to count this 5 again. Oh, gosh. This is where it gets interesting. So I thought we could do it without actually having to actually count the number of frames that we've done. Wow, this is a nasty case. So what do we need to do this? The reason I'm hesitating right now is because the word frames is actually, so let's say scores, and we'll say score. So now let's, haven't gotten any so far. So the only really thing we need to care about is we'll always add a roll. And we want to add another one for a strike because it takes up the second ball in the frame. It's less than, well, what would our total rolls be? 2 times be 20. Let's see what happens with this. Okay, and everything passes. So there we go. So we've got, there might be some redundancy in here actually, because, well, we need the index versus that, so there's not much we can do. So are there any other test cases? I guess there would be. The problem is I don't know what the score is going to be. It's going to do my head in, but let's see. So let's say instead of the last two being that, we had a 9 and then a spare. Oh, jeez, what is this? 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 of those. So actually it's going to be, everything's going to be there except the last one will be 20 instead of 30. So it should be 290. And what have we got? We've got that's interesting. So where is that coming from? What's our stack? Do we have a stack? Here. Oh, because we're not including it in here, of course. And if it's slash, we'll just return 10 as well, because it should hopefully know the cases it needs to for that. Damn. 298. Right. Because it changed this one as well. Is that really the only difference? That doesn't seem right. Okay, let's just do this. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that would be a normal 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the last frame will be 20, because it'll be 10 plus the next one. And this one, instead of being, it'll be 1 less, so it'll be 29. Which seems like 11 less than 300. Be 89. But that's not what we're getting. We're getting something else. So, ooh, this is getting tricky. Let's just run this again, because I want to see what happens. Okay, so it's going to go through. Okay. I don't know how long this video is getting, but see, that's the problem. This isn't actually 10. It's actually 1 in this case. Oh, horrible. That's the problem right there. So this is not right. See, if this was 1, just for grins, just to show. Hey, yeah, everything's fine, but that's not it. So we need to know what the value of this is, and that's really a problem with this sort of thing. See, this is where I would be tempted to the problem is, though, it could be 10. You know, you can't just replace the frames with this. Well, anyway, God, this is really sad to be ending on this kind of note, but, I mean, everything's green. Anyway, no, that's not a good thing to say, but what's the best way to do this? You'd want to know what the previous value was. I mean, you would need to know it. It would have to be 10 minus something, which is whatever the previous frame's value was. But it would have to come in all of these places, every place this frame value thing is used. Actually, you wouldn't have to. It's only because you can't have a spare before or after. But that's a bit hacky. So if we had this is the only place right here that it actually could be different. So I'm going to take this. Because see, this is actually, ooh, this could actually happen elsewhere as well. It doesn't have to be at the end. It could actually be earlier in the game as well. Any place there's a spare after a strike. Right. Okay, well, that's fine. So we can solve this. So let's take this guy and strike score. Actually, let's include this in the strike score, because that's part of the strike score. Now, let's say, okay. Plus 2 equals that. we'll do that. Got rid of all of that, and there we go. So now it's everybody's happy. And we could do the same thing here as well. We could, you know, turn this into another method. Call it a spare score. At least this way, you know, it keeps this fairly sane, and this keeps the logic of these guys in here. All right. Well, I think that's a good place to stop. I should refactor that again, so let's run the tests, and the tests still pass. If there's a test case I missed, I'd be happy to add it in, but that's the thing about this, is that if it comes back later and we've missed something, we could always add in another test case and get it to work, and we know that it doesn't break something else. So this has been a whirlwind tour of bowling scoring with TDD, and I hope it's been interesting. And I hope you got this far, and if you have any questions, let me know. So here's a slight addendum to this video, because I realized as I was watching that I had initially had a proper enumeration, and I switched to be a while loop because I thought I was going to have to increment the index, and it turns out that we actually never had to. So let's do one last refactor, which should clean up this code a bit. So we'll say for index. Oh. Sorry, I think I just realized that there's a bit of a goofiness here, but that's okay. If roles is we don't need that, and we don't need that. And how does that look? Yeah, but it all still passes. So we've now, oops, don't need that either. Okay, so we've refactored our code down a bit. It's a bit annoying that way, but that's the way that goes. So you can almost turn this around and base it on number of roles, but we'll just, that could be an interesting refactoring exercise to do at some point, just to turn it around. And we still have to count the index, but at least then you would just be looping on roles up to 20. Well, except it's not 20. I don't know, it's a lie, so anyway. Okay, well that's fine. That's all I'm going to do for this. So that was our sub-thought and subsequent thought. And now hopefully the code looks a little bit cleaner as our refactoring. So that's all. Okay, we'll do one final bit of refactoring, just because when I was looking through this, I realized it bothered me a little bit that we had this check here, but not here. But then I realized that this code was written before we had this code. And so the thought is, well, do we actually even need this anymore? So let's get rid of that if check, and let's run our tests. And yeah, everything still passes. So this is another case where the evolution of the test means that some of the code could actually go away. And actually, if you look at this, this is actually quite simple code at this point. You know, afterwards, when you get down to it, it's like, oh, geez, you know, I could have potentially come up with that ahead of time. But it's, even if you could, this is what happens when you sort of let the code evolve. It becomes something that even if you don't know up front, it actually works out quite well in the end. So anyway, that was hopefully the final bit on this.